In this video, we're going to explore the GPT Research Assistant, which allows us to search archive paper repository with a search query, for example, coding ability of large language models. Then we retrieve 10 related papers. Then we get their summaries and give each one of them to GPT at the same time, all of them, and let GPT choose the best paper, the most promising paper. And then we let GPT summarize that paper, then pick a new promising search query. And then we use that search query to retrieve 10 more papers, and we repeat this process and many times. You can repeat this as many times as you like. When we run the GPT Research Assistant with a query, in this case coding ability of large language models, it goes ahead and retrieves 10 papers from archive, and then it gives some reasons as to which paper it's about to choose. And then it returns a number. It chose the first paper, number 0, because we are giving the summaries of these to it as a dictionary, the keys being the numbers 0 to 9. And after it summarizes that paper, and it also saves it in a PDF file right here, it suggests another search term, impact of programming language features on code generation models. Okay, after that, it retrieves additional papers, and it chooses another one, and it summarizes it. Then it suggests a new search query, multitask learning and programming language corpora, domain adaptation for sequence labeling using hidden Markov models. And there we go, we get the new papers. And this time it has chosen the third one, 0, 1, 2. And this is the reason why it has chosen it. And this is the summary of it. It also downloads the PDF files, and you can read them in your spare time. Requirements for this project is only OpenAI, PyPDF, and Archive. Code files for this will be available at Patreon. You can download the source codes there. The link will be in the description. We have 4 files we're using to make this run. The GPT-tools.py includes a class for handling messages, message history, and also making a call to the model which we specify. Archive tools.py includes the function which returns the papers by making a query to archive. PDF tools.py has a function which uses PyPDF to extract the text information from the paper PDF file. And then we import all the necessary stuff from the files and also requests and read. And we have another function here which actually downloads the PDF file. Let's run the whole file in debug mode and see how it is working. We assign number of turns for research, here in this case 3. We assign chosen paper to none, just to initialize it. And search term is we start with coding ability of large language models, but feel free to change this to anything you like. And let's do line by line execution. We enter a for loop, and then we are calling our main function, which is the function which accepts search term and chosen paper, and actually runs the app. And then we enter the main function, and we assign a GPT chooser instance from the GPT chat class, which we are importing right here from GPT tools. And this takes in a system message and a model. We have specified the model as GPT-4. We say you're a helpful assistant that chooses most interesting academic paper. Pick a paper which you find most useful and interesting and promising. Explain briefly. We say do not use any numbers in your explanation because we're going to parse a number out of this response. Then return the number of the paper you choose. And then we assign the model. And then next we are getting a list of models from the getArchivePaper function. This function exists in the archive tools.py. We just give it a query and makes results. In this case, we're going to retrieve 10 papers. And when we run this, then we just return the papers. And we convert it into a list because it's an object when we first receive it. So if we look at papers now, we have 10 papers retrieved. Okay, and then we loop over these papers. Okay, and we check if our chosen paper title includes the paper. If there is such a paper that exists in this list, which includes a previously chosen paper, because since it suggests a new search term, it can often retrieve the same paper. And it can have a tendency to choose the same paper again and again. So that's why we are initializing chosen paper in the beginning to none. And then when GPT selects a paper, Then we are going to assign it to that chosen paper, and we are going to remove it if it exists in our new list of papers, okay? But since we're in the beginning, we're not going to have it. Anyway, we're just having this quick little loop to print the paper titles. We can actually skip this step. And then we are going to create a summaries dictionary, but then we're going to stringify it because we're going to pass it to a GPT call. Okay, let's just quickly go over that. Okay, here is our summaries. As you see, we have the summaries of all the papers. And then we're going to get a reason and a number using the GPT chooser. Okay, GPT chooser is a method called get GPT-3 response. If you look at GPT tool, it is a get GPT response method, which takes in a user input and then makes a call with streaming responses. Anyway, we're going to run it, and then we will get a response. Here it says the paper title, large language models have demonstrated the ability to generate both natural language and programming language text is particularly interesting. Actually, it doesn't know the title. It only has the summary information. Anyway, it finds this paper the most promising. This paper discusses, so it explains, and then it says it has chosen the first paper. And then next we do some regex to find the number. Okay. We are checking, say we are parse the number by finding the number in the response, just in case GPT returns more than just a number, while we are actually asking it to explain itself. Anyway, as you see, our chosen number is 0, and our chosen paper is going to be that paper. Here we go. We are checking the 0th element of the papers, and then we are making sure that our file name doesn't include anything that might be illegal for a file name, because we're going to save this to .pdf, and then we assign a PDF file path with this name, and then we're going to download this PDF because we use to be downloaded with using download PDF function, which we have specified in this file, and then we're going to extract the text from that. Here, then we jump into pdftools.py. We have imported this function into our other file, right? So we're going to define a PDF reader, and this is going to loop over and actually return a text. This part takes a moment. And after that, immediately we are summarizing. Actually, we skip this part, but after we extract the text, I am assigning the first 20,000 characters from the paper. You can change this value, but actually, you can also implement a token-based counting as well, if you like. And then we're going to get the GPT summarizer with a system message. We are instantiating it from the GPT chat class. You are a helpful assistant that summarizes academic papers. Summarize the paper in a few sentences. Also return a new promising research term for future research. Turn the research term as research term equals research term, right? And we are, again, using GPT-4. We have gotten the summary. Then we do regex to find the research term. We try with this. If not, we should search for a lowercase, actually. So we just try two alternatives. It usually returns with uppercase S. But anyway, we try that, and then we get the search term here, in this case, multilingual code generation benchmarks. And we return this research term in chosen paper and assign it to new research term in chosen paper, so that when we call this function again, the next time, we are using a new search term, as you see. And then we repeat the process. We are getting the papers with the new search term. Our query is multilingual code generation benchmarks. And then we're going to get the new summaries. And then we're going to get a new reason and a number of the whichever paper GPT chooses. This is quite interesting. I think this can be improved. Like I said, the code will be available at my Patreon. Feel free to download it and make improvements on it. The papers will also be downloaded and saved to PDF so you can read it later. If you enjoy my coding videos, please check out my website, echohive.live. Here you can find all my videos and actually search them. I also recently created a live stream with GPT-4 scientists, which does something Similar to what we just learned to do today, but actually much more complex. It tries to generate novel ideas. Take a look at that as well. Anyway, at ecohive.live, you can search and browse all my AI coding videos, building AI-powered large language model powered apps. You can also find the code download links and their descriptions. It's really convenient. Ecohive.live, link will be in the description. Also, the code files for all these projects, 100 plus projects, is at Patreon, and you can actually become a patron and download them as well. Thank you for watching, and see you in the next video.